This video is meant to demonstrate the particular triangle relationships of a 30-60-90 triangle. In order to do so, we're actually going to be using an equilateral triangle construction, which we will do shortly. When we say triangle relationships, what we're referring to is knowing both the angle relationships, which are just given in the name. It's a 30-60-90 triangle, 30 degrees, 60 degrees, and 90 degrees. It's a right triangle, as well as knowing the relationships between the lengths of the sides. Okay? So recall that when we're talking about two similar triangles, all they need is to have the same angles. If they have the same angles, their segments are all proportional to another similar triangle. So long as we know a generic version of the 30-60-90 triangle, we will know basically all of the 30-60-90 triangles given one side. So we start by creating a equilateral triangle construction, which again, you just create a line segment AB, create two circles that are of that same distance with your compass. Okay. You then draw the intersection between the intersection of two circles and the 2 points, point A to C, and segment C and B. Okay. Recall that by definition, this is a equilateral triangle because all three side lengths are the same. Okay. Well, this is good, but this isn't a 30-60-90 triangle by any means. But if we just bisect this guy, we will bisect not only the segments, but we will bisect the angles. Okay? And the two sides we know are going to end up being congruent pieces, basically because these two sides will be bisected. The segment drawn up, the altitude, median, and perpendicular bisector are all the same for an equilateral triangle, is self-congruent, and you have two right angles. So you have a side angle side for one. You also have another side just for fun. Okay? Plus you also know the other angles. So each part of these are congruent, so we know that this has to be, actually I should do this formally. We're going to take perpendicular bisector of segment AB, which we know will run through point C. Point A is here. And then we draw our straight line through those intersection points and again also through point C. Okay. So we now know that we have a right angle here because it was a perpendicular bisector. Okay. Let us arbitrarily give something a distance. Okay. To find the size of any triangle, you need to know at least one of the sides. Okay. So we're going to arbitrarily say that this has a length 2. Okay. And there's a reason for this choice. Okay. For the equilateral triangle, each of these sides is then 2 units long. This perpendicularly bisects these two segments, so we know that this is exactly 1/2 of that. Okay. So it is actually 1 unit long. 2 and 1. And then to find the other side, well, we just use the Pythagorean Theorem. Okay. So if we want to know Pythagorean Theorem, c squared is a squared plus b squared, where this is always the length of the longest hypotenuse side. Okay. We now have 2 squared is equal to 1 of the legs squared plus the unknown leg squared, which is given right here. It's the vertical height from the perpendicular bisector. Okay. So this, when we do it, is equal to 4 is 1 plus b squared. Subtract 1, we get 3 is b squared. We get the square root of 3 is equal to b. Okay. So b is the square root of 3. Now, anytime you have another similar triangle, the angles are all the same, but you can scale each of the sides by some factor k. So if we double the length of the hypotenuse, say we make this 4, this will still be 1/2 of the original. Okay? It will still end up being 2 units long rather than 1. Okay, so 4, 2, and then this would just be 2 root 3. So the relationship for a 30-60-90 triangle is opposite to the angle that we are describing. Opposite the 90 is 2. Opposite the 30 degrees, we know this because it was an angular bisector, and that this is 60 degrees because it came from the equilateral triangle. The half of this value is the 30 degrees, 1. Okay? And this is just root 3. If we arbitrarily make a new triangle, and let's say the one across from the 30 was, say, 4 units long, this is just root 3 times the sky. This would be 4 root 3. This would be double. This would be 8 units long. Okay. If we instead know, say, that this is 6 root 3, okay, we know that the side across from 30 degrees would end up being 6, and that the hypotenuse would end up being 12. These are the relationships that you have in a 30, 60, 90 triangle. 30 being half of 60 ends up being half of the hypotenuse. So remember, the smallest angle is the one that's half of the largest side.